This is RD Sharma solution. We are taking probability of class 12th. Exercise is 5th. Two cards are drawn successively, one by one, without replacement. Now, without replacement is very important. With replacement, without replacement. Now, well shuffled deck of 52 cards. Probability exactly 1 ace. Now, there are 52 cards in all. In this, we have 4 aces. Exactly 1 ace. So, first ace can come. First card, there are 2 cards actually. So, first will be ace. Second can be any card. The second possibility is the first card can be any card. The second card should be an ace. Now, there are 4 aces. How many aces? 4 aces. We are having 52 cards. So 4 aces are there. 52 cards in all. Now second card can be any of this card. One is already been taken because there is no replacement. So we are left with 51 cards. 52 minus 1, 51 cards. Now you don't want an ace. 52 cards are there. 4 aces are not welcomed here for the second card. So in 52 cards, if you subtract 4 cards, how many cards are left? 48 cards are left. So these 48 are the favorable cases. Now in the second case, first card can be any card except ace. So in all 52 cards, you have to subtract 4 in order to get the favorable cases. So in 48, without the ace card, divided by the total number of cards is the probability of getting a card other than ace. In 52 cards, one has already been taken out. So 51 are remaining. But the first card is not an ace. That is confirmed. So that means 4 aces are still there. So there are 4 aces. So this is the probability of getting non-ace and an ace. First is ace and non-ace. Now this is the logic. But how about writing? So this probability which we are going to find out, or we are finding out, is P exactly 1 ace. So this is equal to probability of first card as an ace plus from here to here, what is the probability? Second card has to be an ace. First card can be any card other than ace. So when you compute this, 52 into 51 in the denominator for both of them. So actually you have to compute 4 into 48 plus 48 into 4 divided by 51 into 52, which comes out to be 32 by 221. So this is very important, with replacement and without replacement. Now this is how you need to write it. Actually this is sufficient in order to write, or in examination this is enough for you. But if you give more intricacy, it will be better. A speak truth in 75% and B 80% of the cases. So 75% of the cases A speaks the truth and B speaks 80% of the time. In what percentage of cases are they likely to contradict each other in narrating the same incident? So there are 2 people, 2 persons, and the input is given is 75% correctness for A, 75 by 100. That is the truth of A is 75%. The second person says truth 80% of the time. So 80 by 100. So 0.75 is the probability of A speaking the truth. 0.80 is probability of B speaking the truth. Now when first speaks truth and second says false, this is the first condition, because they needs to contradict each other. If one has to say yes, other has to say no. So first says yes, second says no, T1, F2. One is for first person, second is for second person. Or first say these first false and second say true. So if we say that T1 is the truth for first one, T2 is the truth for second one, F1 is the false of first, F2 is the false for the second one. Truth plus false is equal to 1 as far as probability is concerned. So the false will be 1 minus truth. So false can be computed here for the first person. 0.75 is the truth. So 1 minus 0.75 will be the false. And for the first person, let us represent it using F1. Similarly, for second person, the false, that is the F2, is going to be what? 1 minus 0.8, because F2 plus T2 will also be equal to 1. So F2 will be 1 minus T2, which comes out to be 0.2. So all the values we have got, let's put in here. T1 is 0.75, F2 is 0.2 for the second person not speaking the truth, and first person not speaking the truth is 0.25, and second person speaking the truth is 0.8. So when you compute this, it is going to come as, before writing the answer, let me tell you how you're going to write it, because you have to write it in words. So P, probability of both narrate different incident, means contradict the same event. Someone says that, oh, I had dinner. Second says, no, he hasn't had dinner. That's right. That's kind of example. So this will be equal to A speaking the truth and same time B is not speaking the truth, or probability of A is not speaking the truth, that is A is false, but B is speaking the truth. So B truth, this will be probability of, in order to write in the probability form, it will be A intersection B not. False is not. A not intersection B. A naught is A false. So A naught intersection B. These are independent events. That is A and B are independent events. So this will come out to be PA multiplied by PB naught plus PA naught multiplied by PB. So what is the probability of A? 0.75. PB bar is 0.2 from here. PA naught is A is false, 0.25, and PB, truth of B, is 0.8. All these values is what when I was discussing the reasoning. When you compute, is going to come as 0.35. Since it is given in the percentage, it will be 35%. So this is how we are going to write. Now this expression is very important in this case. In this type of question, the question is asking to write you the expression, then only you can write the answer. Kamal and Monica appeared for an interview for 2 vacancies. The probability of Kamal's selection is 1/3 and that of Monica's is 1/5. Find the probability that 4 different questions are there in this one question. So one by one, what is given or what is the input, we'll write. So probability of Kamal selection, let us call it as A, probability of A. This is 1/3. Now Kamal not getting selected is what? PA naught, 1 minus 1/3. So select and non-select both combined probability will be 1. So 1 minus 1/3 it will be, that is going to be 2/3. So this is the first case. The second case is same for Monica also. Probability of Monica getting selected or probability of Monica getting rejected. It will be PB, call it as B. 1/5 is given in the question, and not selection or no selection of B is going to be what? 1 minus 1/5. So 4/5 it is. So there are 4 probabilities, different probabilities, which we have deduced from what is given and which we are going to use in computing 1, 2, 3 and 4th part here. The first part is what? Both of them will be selected. That is the probability of Kamal and Monica both getting selected, which is PA intersection B. And since these two are independent events, we can write it as PA multiplied by PB. So what is PA? 1/3. And PB is what? It's 1/5. So this comes out to be 1/15. 5 3s are 15. Now let's do the second one also here. None of them will be selected. So it's simple. A bar intersection B bar. So A is not getting selected, B is not getting selected, neither Kamal nor Monica is getting selected. So these are independent events. So we can write it as PA bar multiplied by PB bar. So what is this? 1 minus PA you can write for PA bar, and then 1 minus PB for PB bar. But these values we have already computed in the beginning. The PA bar we are going to directly write. I'm not doing 1 minus PA. PA bar is already with us, 2/3. And this is 4/5, which is PB bar. So this becomes 8/15. So this is the second one. The third one, at least one of them will be selected, or only one of them will be selected. So we have to write certain expressions. So let's do it. So third one is like this. At least one of them will be selected. So either Kamal or Monica or both of them. That is this. So this will be PA union B, either A or B. So the expression will be PA plus PB minus PA intersection B. And since PA intersection B we have earlier known that they are independent events, it will be PA multiplied by PB. PA is what? It's 1/3. PB is what? 1/5. And PA intersection B, PA multiplied by PB is what? 1/3 multiplied by 1/5. So when you compute this, this is going to come as 7/15. Now coming to the fourth part. What is fourth part saying? Only one of them will be selected. So if Kamal is selected, Monica shouldn't be selected. And if Monica is selected, Kamal should not be selected. So I'll write the expression first, which is PA and A selected, B not selected. So it has to be AND. APA and B bar, or PA bar intersection B. So A and B bar together and A bar and B together. That is Kamal not Monica and Monica not Kamal. Only one of them. Now these are independent events. So you can just write PA intersection B bar as PA multiplied by PB bar. And for the second case, it will be PA bar multiplied by PB. PA is what? It's already given in the question. 1 by 3. PB bar we have already computed. It's 4 by 5. PA bar was what? We have already computed. 1 minus 1 by 3, 2 by 3. And PB was 1 by 5. It is already given in the question. So just write 1 by 5. So the final result will be 2 divided by 5. This is the final probability. Now, how are we going to write this question in a formal way? So this is how you are going to write it. And I hope you understood also the question, the solution, what I have suggested. A bag contains 3 white, 4 red and 5 black balls. 2 balls are drawn one after the other without replacement. What is the probability that one is white and the other is black? So this is a bag we have, and this bag contains 3 whites, 4 reds and 5 black balls. 2 balls are drawn one after another without replacement. There is no replacement. Mind it. One is white and the other is black. So one can be white, the other can be black. So there are possibilities here. First one is white, second is black. So W1, B2. Or first black and second is white. So B1, W2. In order to write in terms of probability, it will be PW1 intersection B2. This has to go hand in hand. Plus probability of B1, that is the black should come first and white should come in the second part or second drawing. And since these two are independent events, this can be written as PW1 multiplied by PB2 and this as PB1 multiplied by PW2. Now, what in words we are going to write? P, that is probability of 1 white and 1 black. So this will be probability of first white and second black plus probability of first black and second white. So the expression which I have written is exactly what I have written in the words. So let's find out the probability so that we can place it here. How many balls are there? 3 plus 4 plus 5. In all there are 12 balls. Now when we pick the first ball, first should be white. That means in order 12 will remain like that. So this 3 white, so 3 by 12 is PW1, 3 by 12. Now the second ball without replacement has to come as black. How many blacks are there? So this is the second ball of the first case. W1 or white ball has already been picked up. So now only 11 are remaining. For the second drawing, 11 will remain. Next has to be black. We assume that the white has already come, but still there are 5 blacks in here. So this 5 is what we are going to use here. So 5 by 11 here. The next one. First case is done. Now we are talking about B1, W2. Black one followed by a white one. Now 12 in all are there in the first picking. First ball is to be black. So 5 black is already there. So 5 by 12 is the probability of getting the first black ball. So just write it here. Now when we pick up the second ball, already one ball which is a black ball has been taken out. So 11 is remaining. Next it has to come as W, which is white ball. And there are 3 white balls. So this 3 by 11 will come. So if you see, the numerator and denominator are similar. So you can just twice it. The final result will be 5 by 22. Now this is how we are going to write about it. If you want to add more reasoning and logic, you can use what I have suggested. A bag contains 8 red and 6 green balls. 3 balls are drawn one after another without replacement. There is no replacement. Find the probability that at least 2 balls drawn are green. Now this is a tricky question. Most of us will think that the 3 balls are coming. At least 2 balls are drawn are green. That means what? I'll give you a hint. But the reasoning of this question will be, we are going to find out at most, see, you can subtract it for something. So when we subtract the probability of at most 1 ball, there are 3 balls. If at most 1 green ball is subtracted from 1, we'll get at least 2 balls are green. I hope you got the logic. So what are all the possibilities? So we have a bag here, and in this bag we have 8 red balls and 6 green balls. First ball is picked up, then second, then third, and there is no replacement. So first green, because we are talking about at most 1 green ball. Either first can come green, either second can come green, or third can come green. This is what we are talking about. At most 1 green ball. So first green, second green and third green. These are the possibilities. And there is also one possibility. There is no green as well. Since all of them can come as red. 3 balls are there. First green means what? First G, then R, then R. So let's call it as 1, 2, 3. So G1 is green first, then red and red. The second case, green has to come in the second place. Third green, the green should come in the third place. And no green means all of them should be green. R1, R2, R3. Now we have to compute the probability of this one. And then we'll subtract it with 1 so that we get P at least, probability of at least 2 balls are green coming. So 1 minus probability of, this is probability of first green. We add all the probabilities, that is the first green, the second green, the third green, and no green. We are adding it and then we are subtracting it from 1 in order to get the required result sought by this question. So 1 minus probability of first green. So this G1, R2, R3. G1, that is green, should come first. In all, how many are there? 8 plus 6 is 14. So we have 14 balls now. One green has to be drawn. There are 6 greens available. Now next has to be a red ball. And only 13 is remaining because one has been picked up. So green has been picked up. The second needs to be a red. 8 reds are there, so 8 by 13. Now one more ball which is red is taken out. In 13, 1 is also picked up, so only 12 is remaining. But in 8, 1 is already been picked up because we need the third as red. So it will be 7 by 12. So 6 by 14, 8 by 13, 7 by 12. All options will give you this only. You will just see. This will come as 336 by 2184. If you multiply this. The next one, first should be red. So 14 are there. How many reds are there? 8 reds are there. So 8 by 14 is the probability of getting first as red. Next one should be green. One ball is already taken, so only 13 are remaining. Second ball has to be green. How many greens are there? 6 greens are there. Now the third one, third picking has to be the red. 2 balls are already gone. So 14 minus 2 is now 12. And in the red, first red is already being picked up. The second red, which is the third red here, is only 7 because one red is already picked up. So this will again come as the same number, 336 by 2184. You know already is numerator has 6, 8, 7. Denominator has 14, 13 and 12. Now coming to the first red, second red and third green. So 14 are total. First red is 8. Second is red. That is 1 is being picked up. So 13 is remaining. One red is also being picked up. So 8 minus 1 is 7. So 7 by 13 will come. Now talking about green, because 2 balls are already been picked up. So 12 is remaining. Green all are available. 6 are there. So 6 by 12 will come. So all the time this 6 into 7 into 8 will come in the numerator. And 12 into 13 into 14 will come in the denominator. It will be 336 by 2184 again. Now no green. That is all has to be red. R1, R2, R3. Let me write it here. There is a less space, so I am writing it here on the left corner. So 14 are there. First is red. So 8 are available. Second time 1 is being picked up. That 2 are red. So 13 are remaining. 8 minus 1 is being picked up. So 7 is remaining only. So 7 by 13. Now 2 reds are being taken up. Only 6 is remaining for us. And in total 14 minus 2, which is 12. So this will again come as 336 by 2184. So all in all, when we compute this, this is going to come as 1344 by 2184. You subtract it with 1, 5 by 13 is going to come. So this was a good question. It is being done, or it has to be done like this. Okay, this is how you are going to write. Now at least 2 balls. That means you can say, because the possibilities are too many. At least 2 balls means exactly 2 is what? Green, green, red. This is just the possibility of getting 2 greens. So GGR, GRG, RGG. So 2 greens are there. At least 2 balls of green means it can be 3 greens also. So these are possibilities you can perform. But this is the better way. And this question we are going to take in the next discussion. Till then, thank you so much. Have a good one.